Now I'd like to introduce the next speaker. That's going to be in Suomi, Finland, Mr. Kari Mäki. He's a research professor at VTT. He's going to talk about harnessing distributed flexibility within buildings, new business models enabled by digital twins. Take a go at it, Kari.
Thank you. Nice to be here. Thanks for the invitation. And I'm also looking to share my screen. Okay, just for a start. So, as mentioned, I'm a research professor at VTT, Technical Research Center of Finland. But actually, at the moment, I'm not in Finland. I'm also in California. So I'm at the moment visiting scholar at University of California in Berkeley. And I will actually be here only like a couple of weeks still. Then I'm going back to Finland. But actually, some of my colleagues from VTT will also come here. So we have like an ongoing presence in California by VTT Energy team at the moment, and that's like a interesting opportunity for us. But and also the topic of today is pretty much around what we are working together with University of California at Berkeley. So I would like to speak a bit about how to utilize distributed flexibility within buildings and what kind of new business models we see maybe raising around digital solutions. But I just wanted to very briefly have a couple of words about VTT. I'm not going to use much time on this, but just for you to know. So VTT is a research and is a research institute in Finland. So it's a technical research institute. You can see some key figures here. We have around 2,000 people, fairly high level of education and so on. And actually, what is maybe important in this context is that we are very international as well. So we have almost half of our turnover coming from abroad. So we are very strong in the EU field, EU projects, but we are also very much present in US, in California, but also beyond in let's say all parts of US. Our role is kind of an applied research institute, so we are somewhere in between basic research and then commercializing the result, funding, let's say, research results into products and so on. And yeah, our smart energy services is a very wide field. So we have expertise in all related technologies, let's say, and also what is important is that beyond technology, which is maybe the key area, we are also very much looking into business models, regulations, markets. So it's very wide approach we do have, and we are of course utilizing modeling and our labs and software tools and everything for good coverage on this area. But that's very briefly about VTT. And I will then start jumping into the actual topic there. So in the big picture, so we are operating in a very sector integrated society, so to say. So we are very much looking across different kind of energy carriers or energy infrastructures, so to say. On the other hand, we are very much enabled by latest like digital solutions, intelligence. So it's kind of interesting to look at different, let's say, intersection points between different energy carriers. Then when you go into these points where, for instance, electricity, heat, and let's say gas are present, and at the same time you also have the connectivity and possibility for controlling and monitoring widely. Those are somehow interesting points where the future can be actually made. So this is kind of a big picture. Then coming to the buildings, I mean, in the very first presentation today, there was an excellent presentation about flexibility. So that's good. So there is clear background for that already given today. As said, flexibility is needed. It's needed throughout the system. it's needed on different system levels, and there are more and more like markets maybe evolving around flexibility provision. At the same time, of course, we know that buildings, they consume a lot of energy everywhere globally, and there are a lot of flexibility options. Normally, such things that have kind of a bit like slowness behind. So we speak about heating, cooling, maybe some kind of pumping, or in some cases, for instance, air pumped air systems or things like that. But there are actually a lot of different possibilities there. Heat pumps is very interesting field, for instance. But when we think about buildings, there are a couple of key challenges, because we are speaking about very small scale, very distributed assets within buildings. So how to reach them in a cost efficient way, that is one, let's say, most important challenge at the moment. And of course, another thing that is very important is always to ensure the primary use, which in the building is, of course, living or working or whatever. So in this case, comfort and conditions must always be remained whenever we utilize any flexibility options there. So we, as VTT, we have been speaking about sub-aggregator model, which is not it's not like a fully new concept as such, but we have taken this through different layers, like technical, business model, regulatory stuff, and so on. And basically, we speak about sub-aggregator in case we have an actor who has like a portfolio of distributed assets. Of course, the actor also knows the process or the service they are providing. One key thing is that they already have like a backend system for communication and control with these assets, and that they also basically have the customer at the same time. So they have the agreement, or let's say agreement towards the customer at the same time, but they are not as an active energy market actor as such. I mean, having any balance responsibility role in the market and so on. And there are a lot of good examples. I mean, EV charging operator can be one, building manager, heat pump providers, different roles. But basically, when we have been speaking about this, we have somehow realized that there are a lot of these in the society. So there are cases like for water system, there are water and sewage pumping stations around, and there are kind of remote connections there. They have the possibility to control, but they have never thought about that, at least so far, at least in the Finnish case. So there are these kind of factors around, and this is interesting. So a bit the same thing in pictures. So we are speaking about model where we do have the, so to say, traditional aggregator towards market, but then we have this more like a technical oriented sub aggregators who have their existing fleets. Here we have like examples: heat pumps, EV charging points, buildings, and they do have the back-end system. And what we now want to maybe achieve is that we kind of do like a single interface on the system level between the aggregator and the sub-aggregator backend. And we already with that gain like a good control over the very distributed fleet behind. And this can open us the possibility to go into to do this more cost efficiently. So basically our model, we are utilizing existing connectivity that is important. We see that if there is a kind of need to go to the asset and install something there, for instance, that already is quite challenging for a business case when we speak about very, very small units. Of course, when you go a bit upper in the scale, like a tens or 100 kilowatt peak power or something like that, then there is still the business case of going there, installing a control box, doing the let's say traditional aggregation thing there. But if we speak about very small ones, we need to be very cost efficient there. Yeah, besides technology, it's very important to also define what are the roles, what are the responsibilities. One like a key maybe question is always what happens when you're not able to provide flexibility, for instance, that you promised. So this kind of responsibilities need to be considered. And of course, one thing is also because we play with very small volumes, very small, basically very small financial amounts as well. So if we are able to integrate this into some other service, such as EV charging service or building management service or something, and maybe we can even include the flexibility value within these kind of service fees instead of having like a separate process for the flexibility related incomes. That can also streamline the process quite much actually. I'm not going into full details. There are different kind of, and I was actually very much already touching these. So the key development areas are to define how to share responsibilities and benefits. On the other hand, how to do the actual interfacing. So there are kind of different options. In the picture we have the EV charging example, but the leftmost through the cloud option is the one that I'm I'm mostly referring to here. So utilizing a full sub-aggregator backend system and kind of distributing the flex requests through that. There are also other maybe more direct options. And as I said, it's important to understand always the primary process, whatever it is. This is again for EV charging in this case. What we did in practice, so we did test this already in our own office buildings and in our campus area at Espoo in Finland, together with companies in a Finnish jointly funded project. So we did have the real market, we had the market aggregator, and we did have kind of different sub-aggregators and different assets behind. And we were exactly focusing much on the information exchange and the business model in this case. So what is critical for the building? I already spoke about this quite much, but what is important is, of course, understand the status of the building, and of course not to harm the actual building use, of course. So in case we do have like an up-to-date digital twin of the building, we can do a lot of let's say better profiling and forecasting in many senses. So we can have real-time measurements on the current status. We can do better controllability. We can do actually a lot of exciting advanced things like a human thermal models or indoor air quality, presence indicators, a lot of things like that. But generally, if we have this kind of a digitally modeled building, we can also have much better awareness while we are taking any kind of flexibility options there, or while we are also planning them. So again, an example, again from our office in this case, but we have also done this much wider in different kind of buildings. So in our office, we are collecting a lot of different data, and we bring everything into a data platform on which we are then running different kind of AI algorithms, online simulators, building information modeling, a lot of things there. And exactly here we are collecting data for energy and power, of course, HVAC system, but also for indoor air quality, pressures, people amounts in the building, different kind of alerts and so on. And also what is very important is actually to have weather data and weather forecast integrated in this. So this kind of an, let's say, playground we have in our own office in Finland. And I have just a couple of like overview buildings on pictures on what we do with this. So we do different kind of things. Actually, we have very exciting things running in the back. So we are doing machine learning for different kind of building related parameters, and they are like all the time running there, all the time learning better how the building will behave in different conditions. And that's actually pretty interesting there. A lot of different things related. Also like a human interface, in the sense that we have a feedback system from the people. And then what is important based on this is that we are able to visualize and do like a good user interface for decision support. So we can, of course, present things differently on different kind of maps, buildings, heat maps, do different kind of dashboards and interfaces and things like that. So, and also what is important is that we can come up from a single building level, and we can do like more like a KPIs for city or district or whatever local level, campus area, whatever level, to indicate how things are ongoing. So just to maybe summarize is that we see that this kind of good digital twin of our buildings can actually be the very valuable feedback when we are doing any kind of flexibility options there. So instead of going too much kind of let's say blinded, doing like a blinded demand response, for instance, we have like an online awareness of what is really happening on site. And that kind of brings me to my concluding remarks. So I already spoke a lot about the building's flexibility potential, of course also the challenges. But as I said, good building management, good building automation, together with like a digital model of the building can really be like a shortcut to assets and utilizing their flexibility towards markets and grid in a cost efficient manner. But yeah, I mean, generally this kind of new business models, they are certainly worth looking for. And I mean, we have been speaking about this kind of models for a while, and actually we have started to see different flexibility and sub-aggregator options basically everywhere where we look. So I think there are a lot of good possibilities ahead as well. So this work also continues together with UC Berkeley, as well as by VTT, of course, back in Finland. Thank you for this.